Welcome back, students. This is the Q&A session 7 from the playlist of oscillations. The topic is the simple harmonic motion. And based on this topic, I have selected one question for this session, which is written here on this board. So here, the question is, the displacement of a particle is given by this equation, that is y is equal to 3 cos in bracket pi by 4 minus 2 omega t, where omega is the angular frequency, which is equal to 2 pi upon t, and where t is the time period. And y here is the displacement of the particle at any moment of time. So we have to prove that the motion is simple harmonic, and at the same time we have to find the time period of this motion. Now the particle which is executing the simple harmonic motion has got the displacement given by this equation, that is d square y upon dt square plus omega square y. This should be equal to 0. So I will be first of all differentiating this equation twice, that is y is equal to 3 cos pi by 4 minus 2 omega t. So dy upon dt will be equal to 3 minus 2 omega, and the differentiation of cos is minus sign, so this will be equal to minus sine pi by 4 minus 2 omega t. So this is equal to 6 omega sine pi by 4 minus 2 omega t. Now I will again differentiate this equation with respect to t, so I will be getting d square y upon dt square. This will be equal to 6 omega multiplied by minus 2 omega, and the differentiation of sign gives you cos. This will be equal to cos pi by 4 minus 2 omega t. So finally I am getting the equation as d square y upon dt square is equal to minus 12 omega square cos pi by 4 minus 2 omega t. Now here the value of cos, in bracket pi by 4 minus 2 omega t from this equation, or can say from this equation, this is equal to y upon 3. So if I substitute the value of cos pi by 4 minus 2 omega t as y upon 3, I will be getting this equation as d square y upon dt square. This is equal to minus 12 omega square into the value of cos pi by 4 minus 2 omega t will be equal to y by 3. So this is equal to minus 4 omega square y. Now we know that the acceleration of the particle which is executing simple harmonic motion is given by the equation, that is d square y upon dt square plus omega square y is equal to 0, where omega is the angular frequency given by 2 pi upon t, where t is the time period, and y here is the displacement of the particle at any moment of time. So if I compare this equation, that is d square y upon dt square plus 4 omega square y is equal to 0, I will get the value of the angular frequency as here, see here omega is the angular frequency. Now if I compare this equation with this equation, then the angular frequency will be equal to 2 omega. Now we know that the time period is equal to 2 pi upon omega. Now since here the angular frequency is equal to 2 omega, so the time period will be equal to 2 pi upon 2 omega, and this will be equal to pi by omega. So first thing is that since this equation, let's say this is equation number 2 and this is the equation number 1. Since equation number 1 and equation number 2 are similar, therefore we can say that the motion of this particle which is executing, the motion of the particle given by this equation is a simple harmonic in nature, and its time period is equal to pi by omega. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the same topic, that is simple harmonic motion. So till then, have a nice day. Bye.